welcome to Upsana Classes. Today in this video, let's learn about the decoders. Before that, the only way to do great work is just love what you do. Okay, let's come to the topic. Decoders. So what is the decoders? It is nothing but getting the original form, so original information back from the encrypted form which we obtain from the encoders. So what is the encoder? What is the work of the encoder? It encrypts the original signal that we have given in a decimal or in octal or anything that we give. It gives in a binary or the priority that we discussed the two types also in our encoder section. So here decoders. Of course, then what will be the inputs of the decoders? Output of the encoders. So let you think, this is the encoders. So output of the encoders will be given to the inputs of the decoders. So what are the inputs of the encoders? 2 power n, which is our original signal. And this is encrypted signal or encrypted information that will be in n lines. So what is the input to the decoders? N line. Then as we are going to get the original form at the output of the decoders, then what is the output? So that is the original form which is in a 2 power n, that we are going to get it in the decoders output. So 2 power n is the output of decoders. Okay. Now see. So as you are having n, you will get 2 power n at the outputs. So which is opposite to what? Encoders. Decoders are opposite to encoders. So see, as it is n, you will get 2 power n, but you are having, for example, decimal. For decimal, you will have 10. Then how would you take the inputs? It's depend upon a 2 power n, where you take 4 digits at the inputs and you will get 10 output signals, where only one of the output is high at a time. Okay, only one of the output line is high at a particular time. Not all the lines are high, but we consider each and every input line. Okay, so let me tell you about the decimal to octal. Decimal to octal. As it is decimal, it's based upon a bits, and octal. As it is octal, you will get 8 output lines. So which satisfy 2 power n, which has to satisfy 2 power n. So for what value will get 2 power n? For 3. When n is equal to 3. Then what are the inputs of the decoder? N. Then what are the inputs we have for 8? So 3. Which is decoder. Okay. So how to represent? So for example, A, B, C, D0, D1 and on D7, where 0 to 7 will get 8 bits. Sorry, 8 lines. Only at a time, only one of the output will be high for the given input A, B, C. So let us assume the truth table. Let's see the truth table. So what is the truth table? Which is the relation between inputs and outputs. What are the inputs we have? A, B, C. What are the outputs? D0, D1, D2, D3, D4, D5, D6 and D7. For 0, 0 0 0 input, D0 will be high and remaining all the lines will 0. Okay, for 0 0 1, if the decimal number 1 is going to represent, then which line will be high? D1 will be high. And on for 2, this is the truth table that is indicating the relation between the inputs and outputs, where inputs are in binary, where output will be in octal. So for 3, this will be high. For 4, T4 will be high. And on for up to 7, because 0, 1, 2, 3, 4, 5 and 6 and 7, as we are taking for octal, BCD to octal, binary coded decimal to octal. If you would like to take for BCD to decimal, then you have to take 10 outputs, and where we have to take 4 inputs, where it satisfies 2 power n, where 4 I have already told you in encoders 2. For 6, where it satisfies 4 to 1 code, so 1 1 0 1 1 1. So here as fifth, so D5 will be on. D5 will be on. This is the truth table that is indicating the inputs and outputs of a decoder, where it is binary to octal. Let's see the logical diagram how we are going to represent for the decoders. As we are having A, B, C, we have to take 3 variables, and one should be given to NOT gate, where if you would like to get at zeros positions, you have to do inversions. So for that case, we have to take NOT gates. So A, B, C. For the representation of D0, if I would like to represent D0, I have to take AND gate. D0 will be output. Where what is the equation for the D0? From this we have to take A bar, as A is associated with 0. We have to take A bar, B bar and C bar. If you would like to get, so how you will see? As it is A bar, B bar, C bar, you have to give to NOT gates. As it is A and A bar, B, B bar, C and C bar. So A bar, B bar, C bar. And if you would like to represent D1, NOT gate, D1, where the inputs are for to make the D1 high, the inputs are 0, 0, 1. So as A is associated with 0, you have to take A bar, B bar and C as it is 1. Okay. So A bar, B bar and simply C. So and on, how many gates you will get? You will get 8 gates as you are taking for the octal. So these are the outputs, and where these are the inputs that are going to give for a decoder inputs and outputs. So assuming 0, 0, 0 to 0, 0, 0, then only this D1 will be high and giving information at this D0, and every D1, D2, D7 up to D7, all the gates will be all the outputs lines will be in off state. Let me write the equation and let you join the connection. D3, D4, D5, D6, D7. This is not D I am taking, this is an AND gate, hope you know. So see, let me write, why to have confusion. Okay, for D2, to have D2 as high, I would like to get the information, then what should be the inputs? 0, 1, 0. So, A bar, B, C bar. A bar, B, C bar. Here, for 3, A bar, B, C. Here, A, B bar, C. B bar, C bar. Here, A, B bar, C. Here, A, B, C bar. Here, A, B, C, as you don't have any zeros at 711 representation. So this is about the decoders, where your information will be converted from one form to another form, where one form your information will be the binary. If you give binary to the decoder, it will give in octal or decimal according to your inputs. Okay, and what are the information that you have given to the encoders previously, you will get it here. So that is the representation. This is the truth table and this is the logic diagram. Hope you understood about the decoders. Thank you for watching. Please like, share and subscribe.